Welcome and thanks for watching. This is the second in a series of web security puzzlers. I'm splitting it into two parts. This video walks through the problematic code and what entails a successful attack. The next one will show how it's vulnerable. The notes below include links to this code playground so you can run it in your browser, and there's also a link there to the last puzzler in case you missed it. If you just want to play with the code on your own, everything you need is in the notes, so enjoy. By the way, I'd like to thank CodePen for making it so easy to share these puzzles. The fork button at the top lets you make your own copy that you can save and come back to. Please imagine that this code is part of a simple web service that might run on Node.js. This code at the top just lets it run in the browser. This exports the only public function, process.json, which is what you're going to attack. Process.json is defined down here at the bottom. It takes a string of JSON as input, parses it, passes it to the process function, and stringifies the result. It also does some authentication. For the purposes of this exercise, your user A123. Process looks at the type of request and then calls a helper. There are three kinds of requests: a request for a user's public profile, a request for the current user's private profile, which includes details that should be kept confidential, a request for a password reset link. The actual code that handles setting a password is not part of this puzzle. At the top here, you see a user database. Pretend that this is an in-memory cache of a database. Again, you are user A123. Here's a table of defaults for unnamed accounts. Here's an in-memory cache of details about password reset requests. Next, for each type of request, there's one function and some helpers. So here's the function that handles the public profile request. Here's the function that handles the private profile requests. And here's the function that handles password reset link requests. I'll let you explore the details of these, but it's worth pointing out that each of these takes information about the current user and the request object, which was decoded from JSON. You might also notice that each of them uses object.assign. That's why this exercise is called bags of properties. Object.assign combines properties from several sources into one object, making sure that the output bag contains each of the properties in the input bags. Now that you've seen the code, I'll explain what it means to win. You win by changing a user record. You also win by forging a record. Maybe accounts are expensive. You can win by accessing another user's personal information. Remember, you're A123 and you shouldn't know other users' real names. You can win by leaking someone else's reset link. Presumably this would let you take over another account. You can also win by making a string you know work as a reset link. You can win by preventing another user from using or resetting their account, or by defacing their account. Maybe by changing Bob's display name to something else. This list is not exclusive. If you find you can do something not listed here, which seems clearly out of bounds, let me know in the comments on the next video. The next video, there's a link in the notes, will go through one successful attack and discuss problems with this style of code. Later in this series, I'll discuss some ways to preserve security properties even when this practice is widespread. Happy hunting!